Guys, let's start our webinar today. So let me tell you what we'll be discussing today. So the first thing that we'll be discussing today is about cloud computing. And then we'll discuss about what are all the cloud vendors that are present in our market now. And then we'll be moving forward to something called serverless. And then we can go to QA session. Okay? So the first one that I would like to discuss with you is what is cloud computing? So it's like I'll tell you what is cloud computing in a very basic conventional way. So this cloud has become a buzzword in the past few years, right? So everybody is using it, and there are tons of jobs that are open for AWS developer or solutions architect. Anything that is related to AWS is quite in demand now. Okay, so first let me start off with cloud computing. So just imagine, like 15 years back, if you want to set up a company, like a product, you want to develop something. Let me tell you that we definitely, back then, you should definitely want something called a data center. So let me explain you what is a data center first. So let me just draw out a figure. So let's just consider that this particular box is a data center, and it's basically a building, a room, a very big house. And then what you need here is racks. So you need racks to place your servers. So this is a scenario that I'm talking about what would have happened if I want to start a company 15 years back. Okay, so back then I would need something called a big data center, and then I need something called
Sorry,
rack.
I'm cutting you, but nothing is. Are you? If you're presenting, nothing is shown.
Okay, sorry. Okay, so I missed that. Can you see my screen now?
Yes.
Yeah, sorry for that. Okay, so first I would say that we need something called a data center, which is this orange color line. And then inside data center, you need something called, you definitely would place something called servers, right? So to place servers, you need something called racks. Okay, so let's just imagine that these are your racks, and then you place servers in your racks, something like this. Okay, and then it's just not enough if you place servers in your racks. For cooling the servers and all, you need something called ACs. You need some coolants. Okay, so in our case, it's just going to be ACs, some coolers to cool all your servers, and then you would need the most important thing. You need people to maintain that. So you need people to put all the servers in the racks. You need people to maintain them, and you need people to give you access. So it's like I'm a developer and I have a monitor here, and I'm a developer. I want to access, I should be able to access a server in the data center. So we need networking also, some sort of connection between the data center server and a developer. A developer should be able to log into the instance. So it's nothing but remote desktop. So let's just consider how expensive this is. Okay, so there is so much high upfront cost. So what are the upfront costs here? The first one is you need to buy or you need to lease a house for this, and then you have to buy a lots of racks. Okay, and then you have to buy servers. These are racks, and you have to buy servers, and then you need to put ACs there, and you need to take care of networking also. So to take care of all these things, you need manpower, right? So let's just imagine that you have started something and it has become very famous. Okay. Can you hear me?
Yes, we can.
Yeah, it's audible.
Okay. So as I was saying, you need racks, you need servers, and you need ACs, and you need people, you need manpower to do this, right? So let's say that you have developed a product and that has become a huge hit that everybody started using it. So in that case, what you should do is you should add more servers, right? So you should be able to add so many servers, and that is costly for you. You need to buy, you need to pay it, and you need to get it, and you need people to fix it and all. One more thing is, let's say that there one more competitor came and then your product has gone down. I mean, the value for your product has gone down. So in that case, there are so many servers that are there in your data center that are useless. So it's nothing but you have so much upfront costs and you have operational costs to maintain people, to maintain this entire data center, and you need 24/7 power supply to that data center. It's going to charge you a lot of money, right? So previously, when like 15 years back, when someone wanted a simple server, first they had to write down all the specifications of a computer, and then they had to place a request, and then they would get the servers after 15 or 20 days. So in that case, this process would take so much time with so much money, right? So now when AWS provided something called EC2, I'll explain about Elastic Compute Cloud, the full form of EC2. It's nothing but a server in cloud. So they came up with a concept called EC2, and then this entire thing has changed completely. Because when, as I told you, to get a server, it would take 20 days in the past. I mean, like before 15 years. But now, in after 2006, they started getting it in minutes. Okay, so they can have a server in 1 or 2 minutes. That was a complete game changer for the entire development. What is that development thing? So let me explain you that you have understood right now what is a data center and what are all the components of it. What are the disadvantages of it? So now let's move on to AWS. So AWS is also a data center, but they take care of everything for you. So if you had seen in the picture, all these components are there in AWS also, but they take care of in any cloud provider in that way. They take care of everything, and you just access the service. So I'll show you how to create it and all. But now this is a sample example that I wanted to tell you the difference between what is a data center and what is a cloud. So now if you take cloud, you don't now if the same scenario repeats in the present situation, what I would do is I would create an AWS account, I would hire few developers, and that's it. I don't need any infrastructure at all. Any cloud server, any cloud vendor would provide me all that I require for developing a product. Okay, so now I don't have any upfront costs, I don't have any maintenance costs, and I don't have to wait for people to do anything. I just can concentrate on what I'm developing. I just can concentrate on my product. So AWS just removes all the burden from the infrastructure provisioning and all. Okay, so that is cloud computing. And now I would like to explain you why this AWS is very famous. So there are many cloud computing providers in picture, but if you see, AWS is the one that is leading. So I'll just show you a small figure for that. That kind of explains why AWS is the market leader. So if you see this figure, server capacity. Server is nothing but, let's say, your laptop. Your laptop is server. But when you want to access it through AWS, that is also a server only, right? So AWS has almost 6 times more capacity than all other competitors. So there are many competitors now. So let me show you who are all the competitors. So there is something called magic. So this, I guess this will explain you what we are talking about now. Just give me one moment. Cloud Infrastructure 2019. So if you see this figure, there are so many competitors for us now. So Microsoft is there, Google Cloud is there, there's something called Alibaba Cloud, Oracle Cloud, IBM Cloud and all. But if you see in this figure, the leaders are AWS, Microsoft and Google. So when I started learning AWS, these Microsoft, Azure and Google Cloud were also in this quadrant only. Only AWS was the leader. Let me explain you why. When nothing was present, when getting a server was more difficult, AWS came up with this solution, right? So from the moment, AWS always gave the best and they keep updating everything. So that did not give so much chance for others to grow, basically. And nowadays, this Microsoft Azure and Google Cloud are they are also expanding, and people started using Microsoft Azure and Google Cloud also. But still, AWS is the market leader, and it will definitely be. Okay, so now it has server capacity of almost 6 times of all the other competitors, including Microsoft, Google, Oracle, and all. And now, if you see, this is a total worldwide market share. 69% of the people are using AWS only, and only rest 31% are using the other cloud providers like Microsoft, Google, and all. Okay, and flexible pricing. So when I was explaining you about data center, you kind of might have got a doubt. So here also you will provide infrastructure, no? How do you actually reduce costs? So there is something called flexible pricing. There's something called pay as you go. It means that you only pay for what you use. So I'll just show you practically for what I said, pay as you go model. So what I'll do now is I'll just log into AWS console. Okay. So this is AWS console. You log into the console, and trust me, you can create a server in minutes. I'll show you how, and you'll get to know. Okay, so first you have to provide the credentials. And now if you see, this is the console of AWS, and AWS is all over the world. They have data centers in these regions. If you see onto the right, these are all the regions where AWS has its data centers. Okay, so now there's, as I mentioned, that there's something called EC2. EC2 is nothing but a server. Okay, so 15 years back, people had to write requirements, they had to submit requests, and then after 15 or 20 days, they'll get the server. So now I'll show you how we can get it very easily in a couple of minutes. Okay, so this is launch. You just create an instance in like 50 seconds. So you can see me. So here you can see the screen. So here you will select what is the operating system that you want. You will select the size of the instance, and you will select different things, different other configurations for your instance, and then you can create it in seconds. Right? So it's just this much. You can just get a server in 2 minutes. Okay. So now, why do I need a data center? Why do I need people to maintain it when I get a when I can get a server for in 2 minutes from AWS? Right? So this is why people are moving from data center to AWS cloud. It's because they don't have to maintain the infrastructure anymore. So in this case, I don't have to take care of this server at all. So this server that is being created, I don't have to maintain it at all. I can just concentrate on the application I'm developing and different other features that I can add to my application. So I don't have to worry about the infrastructure at all, right? So this is the AWS console, and this is how you launch a server in AWS. So now I'll tell you something called serverless, and trust me guys, serverless is going to be the future now. So this AWS, when it came in 2006, many things have been changing. Okay, so let me just draw it out for you. I'll explain you what is serverless now. Okay, so let me just remove all of this, and then let me start off like 15 years back. Like 15 years back, what they used to do is they used to have a data center, right? If we just discussed about it, they used to have a simple data center, and they used to have people who can take care of the data centers, and developers, they access the servers and data center remotely. Okay, so the disadvantages of data center is that you have so much upfront cost, you have resource, it's like when your application is a big hit, you have more servers that are in use. But otherwise, if it is not, then you have so much infrastructure being wasted in your data center. So it has high upfront costs and operational costs, because you need people to maintain the data center, and you need all the other things like a house, a coolants, 24/7 power supply for all the servers and all, right? So this was the first thing. And then in 2006, AWS came up with something called EC2, and that was a complete game changer. Okay, so previously, if you think in data center, they used to have servers, and then they used to deploy applications in the data center, right? So after that, there are certain disadvantages in data center that led them to use something called virtual machines. Okay, so I'll tell you what is virtual machine now. So I'll just draw out a diagram. This is a virtual, this is a virtual machine. These are all the virtual machines. And then I have the underlying infrastructure. I have something called hypervisor. I'll explain you all this. And then these are my virtual machines. Okay, so let me just write it out. This is VM. This is something called a hypervisor. And there is something called infra. And in here we have app, our app. Binaries and libraries. And we have something called guest operating system. So it's the same in other virtual machine also. You have something called guest operating system, application, and binary. So if you see, after data center, they came up with something called virtual machines. So what is a virtual machine? It's nothing but an independent unit of computing software. It's nothing but a computer. And they used to deploy applications in the virtual machines. So if you see, each virtual machine will have an application, and any application will need some required binaries or libraries, right? So these are the binaries and libraries, and each virtual machine will have a guest OS. Okay, so this guest OS can be different from the entire, can be different from each virtual machine. So this is the infrastructure.
Hello, Anuj, this side. What exactly is guest OS?
It's nothing but any operating system, Windows or Linux or whatever it is, but it is there in virtual machine, right? So I called it guest OS. So this entire thing will also have operating system. So I call it guest OS. You can take it as operating system.
Okay, so can we have multiple virtual machines?
Yeah, there can be multiple virtual machine with different operating systems.
Okay, so different operating systems on different can run on different virtual machines, right?
Yes, yes.
Okay, sure. Thank you.
Yeah. So different virtual machines will have different OSs, and this is infra. So what is infra? Infra is nothing but CPU, memory, all the other resources. So you have so many virtual machines, and you need someone to maintain all of them. You need someone to distribute the infrastructure between different virtual machines. So here the hypervisor comes into picture. So hypervisor is the one that takes care of distributing or allocating the infrastructure resources to the different virtual machines. Okay, so this was fine for some time, and then people were like, okay, so each virtual machine having an operating system is heavily weighted. It's like uh, operating system is obviously heavy weighted, right? It takes most of the memory, right? So and then they thought about it, and then they came up with something called containerization. So you might have definitely heard about the term called containers. It's a buzzword now. Everybody started using containerization, and trust me guys, it really makes our lives very easy. Okay, so now I'll explain you what is a containerization. What does it mean? So if you know about containerization, there's something called Docker, which is very famous. So I'll start about telling you what is containerization. So it's the same figure like what is virtual machine, but there's one difference. One difference is, I'll just write it out for you. So this is a container. This is another container. And there is something called okay, so here it's infra OS, and this is something called any container engine. So if you take Docker, it can be Docker engine, and then these are containers. And the one difference that is there between virtual machines and containers is that you don't have operating system on the containers. So it's like you'll just have the required application, and you will have binaries. Okay, so the required binaries and libraries. So I'll explain you clearly what it means. So let me just tell you. So this is the infrastructure as we already discussed, and this is the operating system of a server. So this entire thing is a server. This is a server. And then inside the server, you have something called different containers, and each container will have an application running on it and the required binaries and libraries only. So it won't have operating system, entire operating system installed on it. So this makes containers very lightweight. So including the application, including the binaries and libraries, it would be in MB or at max GB. So it is very lightweight, and you create it once and then use it anywhere. So let's just imagine that my operating system is Linux, and I can run Ubuntu and other flavors of Linux, right? So I can run applications on different flavors of containers. And this is actually in boom now. Everybody is using it. Wherever you see, you might have heard about containers and Kubernetes. Okay, so those two are being used rapidly now, and this is what is a container and all. And so what are the disadvantages of this container is that you have to maintain these containers, right? So if you see from the beginning, our lives are becoming easier, right? If you take from the beginning, from the data center, moving from data center to AWS cloud, having virtual machines in seconds, it has made our life easier. From virtual machines to containers, it still made our life easier. But now they wanted something which is more flexible, okay? Even in this, they have to maintain something called containers, okay? So now if you feel like, I don't even want to use containers, I just want something where I can deploy some application and I don't have to take care of the underlying infrastructure, I don't really care where it runs. So that is going to be future, which is called serverless. So there is something called serverless. It's like you won't maintain any underlying infrastructure at all. What you will do is you'll just log into the AWS console and you will ask for whatever it is and you'll deploy whatever it is. So today we'll talk about a simple example for this serverless architecture. So our AWS provides a serverless service called Lambda. Okay. So now today we'll be discussing about Lambda, and I'll just log into the console and I'll show you what is Lambda. Show you the console, but before that we'll discuss a bit about Lambda. Okay. So now guys, if we want to run a Java application, what all do we need? We need run, or if we want to even develop a Java application, you need many libraries. Like you need JRE, runtime environment, and you need Java development toolkit. You need all of them installed in your system to execute a Java code, right? So likewise, let's say you are developing a simple script for Python. So in that case, if you want to test that Python script, if you want to develop that Python script, you need Python installed in your local system. Okay, so and then let's say you have developed something in 2.7 version of Python, and then you also need to develop something in 3.7, 3.6 or 3.7, the latest version of Python. So in that case, you will need 2 versions of Python in your local system, and you will have to maintain it's like you have to make sure that they don't get conflict. You won't get any conflicts of having 2 or 3 different types of versions of Python in your system, right? So these are the two things that you would need. And if you take .NET also, you have many different libraries that you need to execute a .NET. So now what if I show you that there's something in AWS console, there is a service called Lambda. You can just log into that and you can execute a JavaScript. Java code or .NET code. So we'll just get started on that. So this is the AWS console. I just created this instance, right? So now it's as easy for me to go and stop it. So it's like initially I told you something called flexibility in pricing, right? So what is it? I also mentioned a word called pay as you go model. It means that you only pay for what you use. So a couple of minutes back, I created this instance and now I'm going to stop it. So once I stop it, what happens is I only pay for the past 10 minutes that I use the system. Okay, so if I leave it in stop state for months also, I won't be charged at all. So you only pay for how much time you're using the infrastructure. Okay, so now I don't want this instance at all. So if it had been the traditional way, getting an instance takes 15 days and then decommissioning the instance also takes so much time, right? So now using a cloud, using an AWS thing, you can just go and terminate it. I don't want the instance, I don't have to pay for it, and that's it. You got the instance in 2 minutes and you can just delete in 2 minutes, right? So how flexible is this? Okay, so then I was discussing about Lambda, right? So this is Lambda. So if you see, the description of it is run code without thinking about server. It's nothing but you don't need any server with the required dependencies to run a code, to run a script. Okay, so now I'll just go and create it's nothing but I'll just show you the basics of how you can execute a script. So if you see the function name, you can give whatever it is. And this is the important thing. So if you see runtime, so what script do you want to execute? Is it a .NET script, Go script, Java or Node.js or Python or Ruby? So if you see for Python only, they support 4 different versions. So starting from 2.7 to 3.8. Okay, so you just select what version you want. I'll go with Python 3.8. So now I want to execute a Python script. I want to test that script, but I don't have Python in my local. So I don't have to worry at all. All I'll do is I'll just go create a function, Lambda function in AWS, and I will be able to execute the Python script. So the function is getting created. So let me just show you where actually I'll be writing the script. Okay, so now if you see, this is Python. Okay, so this is the main function that will be executed in the Python. So I can just go write any number of lines. Okay, so it can be any number of lines. Whatever that you can write in your local system, you can write it here, starting from a hello world program to a very complex Python code also. You can write it in Lambda. Okay, let me just go and save it. So it's as simple. You just write the script, you save it, and you test it. So now if you see, it has executed. Now I see the output as hello. Okay, so isn't this very easy? You just execute whatever the script you want in whichever the language specified and runtime in seconds. You'll get it ready in seconds.
I have one question here. Do we only have one day?
Hello?
Yeah, hello. I'm audible.
Okay, your voice is very low.
Okay.
Yeah.
So is it better now?
Yeah, it's better now.
So I'm asking, only these runtimes are available, or do we have any more runtimes as well,
Right
like
now,
Angular or Node.js?
Yeah, right now AWS supports only these runtimes.
Okay.
Yeah.
I do have a question.
Okay.
So is this the Lambda is only about running some script, or I was expecting that we can also deploy some application altogether. Is that also possible here?
Yeah, that is also possible. How you do that is you can just have the entire Python script in a zip file, and then you can upload it.
And how about the external API calls? Could that be happening from inside?
So there is something called, so if your application is completely hosted in AWS, then you will use something called API gateway for the API calls and different services for your different requirements. So in that case, you will be able to use Lambda properly.
Okay.
Yeah. So this is as simple as that.
I have one question here.
Yes, go ahead.
In case of .NET, we have to run some library to execute.
Okay.
That library to be some code, DLL or some assembly code will be there, right?
Okay.
So I have to deploy that assembly somewhere, the code.
Yeah.
Or running that one.
Yeah, in Lambda, what you will have to do is when you have requirement for different libraries and all, you have to create a zip file of your .NET application, and then you will have to upload it to Lambda. So if you see here, you have an option called upload a zip file, right? In that case, you can upload the zip file and Lambda will take care of it.
So how the system, that Lambda know that this the zip file contains this particular library to be executed?
Okay. Are you talking about execution? Okay, you're talking about execution files.
Yeah.
There are some specifications that you will have to follow when you upload a zip file to Lambda. So in that specifications, you can specify. It's like what is the main thing that should be executed and all. You will specify all that before uploading a zip file.
Okay.
So it has to be a zip one. I cannot upload a React.js application probably. Is that possible?
It has to be a zip file.
Oh, okay. Then a web application is not applicable here.
In the web app, there is Node.js is also specified here, right?
Right, but they would be, if I create a zip, those would be, executable files.
Okay.
But Node.js only support the server-side activities, not about the websites.
Right.
The HTMLs and other things are required to run the websites.
So it seems that a full-fledged application cannot be hosted.
If it is a static website, then you
No,
have
even data-driven websites are also there. The application websites are there. The user can put the data in the web pages, then the data go to server and they get the data back.
Yeah, there are different services that are in AWS that can do that task for you. There is something called Elastic Beanstalk, wherein you can just deploy an application. So this, I'm not sure how you deploy an executable file here. This is to run code specifically.
Is it all are serverless or just this is the Lambda is serverless only?
Lambda is serverless, and Elastic, the other services that I told you, that will charge you a bit.
So that means we had to have some servers first before using serverless also.
Yes. So this kind of Lambda I'm talking about, the scenario I'm talking about, will be helpful in some scenarios. It's like, let me give you an example. Okay, so you have many websites on the internet, like convert an image to a different size, or create a collage of different images, and then convert an Excel file to XLSX. So these kind of functionalities, let me just draw out a figure for you. So this is me. This is a simple web page. So where I can upload a file, and then I want the functionality. So let's say you want to deploy an application that converts XLS file to XLSX. So in that case, you need to deploy something, right? You need something to take care of your application. So if I were to do that in AWS, what I'll do is I'll use something called API gateway, which is also serverless. So that API call will directly trigger my Lambda here. Lambda will take care of converting the file XLS to XLSX, and then it can send the output to the web page again. So this kind of applications, simple applications, I can take care using Lambda. So, but if you want to deploy an executable file, complex files and all, you would have to use other services.
Okay. So it just means that if you have to do small tasks like converting a file or reading some data from some
that is a simple thing I told, but if you still want to process, if you still want to add functionality, you can still add, but not.
Can I deploy our web services on the using Lambda? Like our Node.js scripts are all basic website web services only. RESTful services are there. So can we use as serverless for the Node.js library here? Like I can complete my server.js file, the Node.js. Is it possible to access from a website to that Node.js library, web services?
Yeah, it should be possible. But most of the time, they don't prefer Lambda in such cases.
I don't think that would be possible because
no,
here
it is not possible.
What I understand is if you put a Java file, then it will run that Java file using the Java runtime, only that much.
Yeah, this is specifically to run code only. You have other services to take care of that. But if you want to display the web, I mean, you're talking about Node.js applications, right? So
Yeah,
Node.js is, I think we can do that.
in Node, if you write Node.js services, like web services are created in Node.js, which exposes the web services and access to some particular public IP or.
No, that kind of things we cannot do it in Lambda.
I think for that you have to host it. Right?
Yeah, for that things you have other services in AWS.
Yeah, that.
So you an EC2 or more advanced.
What I understand from this one, that Lambda is just a process which help you to run like a background services, like a Windows services we run in the data in the background, which are running in the background continuously doing their task only.
No. I don't know.
Not like Windows services. It's basically some script that
It's
runs.
something like that. Some activity to be done in the background. Nothing to be required in server activities for the server there.
Yeah, something happens in the background and it gives you some output.
Yeah. Okay.
You give some input, Lambda processes it, and then it gives you some output.
It's probably good for a batch processing.
Yeah, batch process. You can batch process. Yeah. Okay.
For the scenarios you told, there are different services that can take care. So if you see this is compute, there are different sections of services that AWS provides. So the first one is compute. So EC2 is a server that we discussed.
Tripura, I'm sorry to interrupt. I'll just add few points here. I don't know who have asked that question, but still, if you want to run some services which are like RESTful services, you shouldn't prefer Lambda. Lambda just for executing your logic, for instance, which leaves a short amount of time for less than like 30 seconds or
Yeah, I
like
got it. That's
15
what I
minutes
understand.
execution time.
I got it. This is the batch process
If you want to go for any batch processing which is taking lot more
Yeah,
time,
that's I
like
understood. Yeah,
you
that's
can go for Fargate. You can go for Fargate, ECS Fargate, which is far
okay.
better than this. You only go for Lambda if it is for short logic.
Okay.
And do you have anything similar, I mean, serverless for actually deploying some application, web application probably?
Probably you can go via API gateway. Like from API gateway, you can expose your Lambda functions, and from there, from API gateway, you can just get them up and running. The only caveat here is, see, it's not a full-fledged API, RESTful API services provider. Like it's just letting you to expose your service in such a way that you can have your application up and running, and just as acting as an endpoint. It doesn't mean that you can use this as a RESTful API service and consume it at the other end. If, for instance, if you want to call some service, and you can use this API gateway, and you can just call the service, get your response, and let it be short-lived. Fine. I'll leave it here. Thank you.
Yeah. So API gateway is nothing but you have this APIs, right? From where you get the information, post the information. If your simple scripts are hosted in Lambda, and then you want to hit the Lambda with API gateway, that is possible. It's like when I want to get information when I hit a API. Okay, so that is possible. And Lambda, it can execute for 15 minutes. And also if you have something that you want to do, like if that takes 30 minutes or 40 minutes, what you can do is you can split the computation into 4 or 5 lambdas, and then there is something called step function. So after execution of one lambda function, it automatically executes other lambda function. Okay, so that even if it takes more time, you can just split it into different lambda functions, and then you can just execute it that way. And Fargate is they specified that we can use Fargate, but Fargate is for containerized applications. So when you have many containerized applications, like I showed you in the previous figure. So there are many options in compute that you can use. That is ECS, Elastic Compute Service, and EKS, Elastic Kubernetes Service. So these are the services where you can deploy your Docker containers, and then there is something called Fargate, which is also serverless, which is used for deploying containerized applications. Okay. So this API gateway and Lambda is like, let's say, let me take the previous example only. So this is my web browser, and this is my Lambda. So I use API gateway, and my API gateway sits somewhere, sits here. This is my API gateway. I'll use API gateway. I'll create an API in the API gateway, and I'll use the post or put method to upload an object to another storage service using API gateway. So that's like this. You can just create APIs, and you can use those APIs to hit different Lambda, different other services in AWS. It's like I can upload objects using put and post method of the API, and I can get the objects using put and post method. And I can also trigger Lambdas using the API. So let's say someone hit the API get, and the API gateway is connected to Lambda, it returns some information. So even if you see now, I created a simple Lambda function, right? So now if I connect that Lambda function to an API gateway, you have something called Postman. So Postman is where you, I think I have it. Let me show you. I think I have done it previously. You can see the output if there is. So Postman is nothing but you can get the information from any API. So you can see you can put, get, or different methods. And this is actually my, if you see, this is actually my API gateway. This is actually my API gateway link. And if you see, whenever I hit that API gateway API, when it is connected to Lambda, it returns me an information. Okay, so that is possible, like integrating AWS Lambda with AWS API gateway. So we are open for question and answer session. If you have any doubts, you can ask me. Can you all hear me?
May I ask something about Fargate if that's visible here?
Fargate?
Hmm?
Yeah, sure. Ask me.
Okay, so because it is serverless, so how do we manage the deployment patterns there? I mean, if I want to do a blue-green deployment.
So I hope you are aware of containers, EKS and all, right?
Mm-hmm.
That case, I can explain you with a figure. So
Okay.
it's going to be like this. So when you have, whenever you create any EKS cluster, this is my EKS cluster with, let's say, sorry, just give me one moment. So this is my EKS cluster. I create my EKS cluster. And normally what you do is you add different nodes to it, right? It's like EKS, and I should have nodes in EKS. And nodes are nothing but other servers only.
You mean the slots?
Yeah. So these are servers. And then you create namespaces and you deploy your containers, right? So now you want to get rid of this entire servers only. So you don't want to use service at all. You don't want to take care of all those servers and all. You want to just get rid of that headache from you. So AWS has come up with something called Fargate. So in this case, what you do is you just create an EKS cluster, and then there is something called Fargate profile in EKS. Okay. So what you will have to do is you have to create something called Fargate profile. And then this Fargate, when you create a Fargate profile, you have to specify the name of a namespace. So let's say that the namespace I want is test. Okay, test is a namespace. Okay, so I create a Fargate profile, and when creating it, while creating it, it asks me to give the name of a namespace. So after doing this, it will create a namespace. So it will create a namespace. And normally what you would do is you will connect to the EKS cluster using kubectl, right? So after adding the Fargate profile with the namespace test, if you use kubectl get namespaces, you will see the this namespace in the list, the name of the namespace in the list. So here you don't have any infrastructure, you did not create any nodes, but still it has created a namespace for you. And likewise in the deployment.yaml and so in the deployment.yaml, you will specify the namespace, right? So you can just specify this namespace test, and then and you can just apply that configuration. It will create a pod in this namespace for you. So that is why this Fargate thing is serverless, because you're not creating any nodes here, and you really don't know where actually your pod is running, but it is running somewhere, and you are not taking care of the infrastructure.
Okay, that was insight.
I have one query. Using Lambda, how we manage the version controlling of the Lambda expressions?
Yeah. So in Lambda, did I close it? Just a second. Let me log in again. So in Lambda also you have something called version control. So let's say you have developed something and that is in production now. And in the same Lambda function, you can have one more version of it, and you can keep developing it. And likewise, you can have different versions. So let me show you. Test and see, if you see here, you have something called publish new version. So let's say that I've developed something and then I'll just deploy it, and that I'll just publish a version. So that will be my first version. So let's say this is my first version. So this is my first version. And then now if you see here, I have two things over here now. So this first one is the one that I deployed previously. I mean, I created a version, and now the present one is latest. So I can still make my changes in the latest one, but I cannot really modify the first version. So once you create a version, that will not be writable again. You cannot modify it. So likewise, you can create different versions. So one can be your development one can be your QA one can be your demo one, and you can.
How we can see the history of the changes we done, and who done the changes for that particular Lambda expression?
So whenever you have something called CloudWatch logs, so the execution logs and all will be stored in that. And making changes, all the changes that you make to your Lambda are actually recorded using CloudTrail. So CloudTrail is a service that monitors all the resources in your AWS. I mean, who is using what user is doing, accessing which service, who is modifying what. So all these kinds of things is taken by a service called CloudTrail. And all the execution logs of this Lambda are stored in something called CloudWatch. So there are two different things. And even when you click a button also, that's actually an API call in the backend, right? So all that API calls are stored by CloudTrail. You will have each and every log of what actually the person is doing in the AWS. console.
Okay. So we have to buy any services for that CloudTrail also.
So CloudTrail, if you really want very detailed monitoring, you should enable it, and you should enable the CloudTrail, and it's quite expensive. I mean, you need it, right? Because if you have important services, then you will have to enable it. And if you see track user activity,
developers are working on the particular activities, and if we have to manage like we can do the source control in the system or somewhere TFS or Git or SVN. But
okay.
if you're saying that this Lambda expression directly to be written in the console only, then
Okay.
how we manage the history of the changes and without having CloudTrail? That's another thing we have to look in that one.
Okay. You want to manage the history of your Lambda function?
Yeah, because there are so many people are working in my team. If somebody change the code and something goes wrong, how we trace down who done the changes and what changes done, and how the code review happened for the particular changes done by the developers.
So that thing you will have to do it in CloudTrail only, who modified what, and then code reviews and all, you will just have to log into the console and do it. So if you really want something called SVN and all, there is an option in AWS. You can actually have that in picture, and then you can approve it, and then someone can make changes to Lambda. So directly you won't give access to Lambda to everybody if it is a production one. What you do is you can have the Lambda in some SVN, and there is something called code commit for that, a version control system, and then you can approve it there. So you can raise a pull request, and then you can give access for them to upload the to update the Lambda. So you can restrict people from not touching the Lambda at all. So based on, you can give granular permissions for your users.
Without changing the code and without testing, how? So
obviously, it's like you won't touch your production Lambda, right? You will have some sandbox account.
So that means you have to create some, even sandbox also.
Even sandbox also you. So then what happens is you will have to create different Lambda functions, and then you will have to monitor in the same Lambda function. If so many people are changing, that's really not a good practice.
Okay, fine.
Any other doubts?
No.
I really hope you enjoyed this session. It was really nice talking to you guys. So if you have any doubts regarding anything, you can contact me on my email address. I'll be happy to explain.
It was really good. Thank you so much.
Thank you so much.
Thank you.
Thank you.
Thank you, Gananas.
Thank you, Harry.
Yes, yeah, thank you. It's Mangesh.